So coupling and cohesion. Coupling and cohesion can come for 10 marks or it can come for 5 marks also. So coupling and cohesion, module coupling. In software engineering, the coupling is a degree of interdependence between software modules. Two modules that are tightly coupled are strongly dependent on each other. However, two modules that are loosely coupled are not dependent on each other. So the two modules, if they are tightly coupled, then they are strongly dependent on each other. If they are loosely coupled, they are not dependent on each other. Intercoupled molecules have no interdependency at all within them. So module coupling, the first case is no dependencies because they are not coupled. Second case is they are loosely coupled, they have some dependencies. And in the third case, they are highly coupled, that is, they have many dependencies. A good design is the one that has low coupling. So a good design is what? Is the one which has low coupling. You should have always a low coupling and high cohesion. Then only it is a good designer. Coupling is measured by a number of relations between the modules. That is, the coupling increases as the number of calls between the modules increase or the amount of shared data is larger. So if the amount of shared data is large, then the coupling will increase and therefore it will cause complexities. Thus, it can be said that a design with high coupling will have more errors. So a coupling, when you are having high coupling, means you have more errors in your design. Types of module coupling. There are various types of module coupling. So this is given the worst, and as you are going above, you are going to the best one. So no direct coupling is the best coupling. Data coupling, stamp coupling, control coupling, external, common and content. So content is the worst coupling. No direct coupling. There is no direct coupling between M1 and M2. So they are not coupled directly. In this case, modules are subordinates to different modules. There is no direct coupling. Data coupling, when data of one module is passed to another module, it is called as data coupling. Stamp coupling, two modules are stamp coupled if they communicate using composite data items such as structure, objects, etc. When the module passes non-global data structures or the entire structure to another module, they are said to be stamp coupled. For example, passing structure variables in C or object in C++ language to a module. Control coupling exists among two modules if the data from one module is used to direct the structure of instruction execution in another. External coupling arises when two modules share an externally imposed data format, communication protocols or device interfaces. This is related to communication to external tools and devices. Common coupling, two modules are common coupled if they share information through some global data item. Content coupling exists among two modules if they share code, example a branch from module into another module. Next is module cohesion. In computer programming, cohesion defines the degree to which the elements of the module belong together. Thus, cohesion measures the strength of relationships between pieces of functionalities within a given module. For example, in highly cohesive systems, functionality is strongly related. Cohesion is an ordinal type of measurement and is generally described as high cohesion or low cohesion. Cohesion is what? It is a strength of relationship between the modules. What are the type of cohesions? Functional cohesion, sequential cohesion, communication cohesion, procedural cohesion, temporal cohesion, logical cohesion, coincidental cohesion. So the worst is the coincidental cohesion and the best is the functional cohesion. Functional cohesion is said to exist if the different elements of the module cooperate to achieve a single function. Sequential cohesion. A module is said to possess sequential cohesion if the element of a module form the components of the sequence, where the output from one component of the sequence is the input to the next. Communicational cohesion. A module is said to have communicational cohesion if all the tasks of the modules refer to or update the same data structure. Example, the set of functions defined on an array or a stack. Procedural cohesion. A module is said to be procedural cohesion if the set of purpose of the modules are all parts of procedure in which particular sequence of steps has to be carried out for achieving a goal. Example, the algorithm for decoding a message. Temporal cohesion, when a module includes functions that are associated by the fact that all the methods must be executed in the same time, the module is said to exhibit temporal cohesion. Logical cohesion. A module is said to be logically cohesive if all the elements of the module perform a single operation. For example, error handling, data input and data output, etc. Coincidental cohesion. A module is said to have coincidental cohesion if it performs a set of tasks that are associated with each other very loosely, if at all. Next is difference between cohesion and coupling. Coupling is also called as inter-module binding. Cohesion is also called as intra-module binding. Coupling shows the relationship between modules. Cohesion shows relationships within the modules. Coupling shows the relative independency between the modules. Cohesion shows the module's relative functional strength. While creating, you should aim for low coupling, that is, dependency among modules should be less. While creating, you should aim for high cohesion, that is, a cohesion component or module focuses on a single function, that is, single-mindedness, with little interaction with the other modules of the system. So it is within the module. So within the modules, you should have very high cohesion. They should interact with each other. But between two modules, so suppose this is module 1, this is module 2, within module 2, whatever are present, they should have a very nice relation. So we say high cohesion. But module 1 and 2 should not have a nice relation with each other. So we say it should be low coupling. In coupling, modules are linked to other modules. In cohesion, modules focuses on a single thing. So they focus inside their space only. Whereas in coupling, they are linked with other modules.